that's the idea I thought maybe I should do differently, because you will definitely forget what I'm going to say today, and in order for you to really have that thing available with you every time, that's the plan. And we have a lot of videos, and most of the videos are about the session that has happened over here. So if you really see a faculty over here and you think, oh, he did say something, but what did he say? So I've got a whole sort of DVDs. I can carry those DVDs at home. You will issue those DVDs. These DVDs are about the C fundamentals, operating system fundamentals, real-time operating system, ARM programming. Those are the DVDs, full-fledged video session. So that's for you to really have it whenever you feel you want to really take a relook at what is happening in the class. Those are the facilities. I'm broadly here for mainly a reason that for you to tell why you are here. You know definitely why you are here, but I'm going to re-insist and also redefine the reason that you are here. This is the product I have got with me. That's one part of the product. Now, if you see this hardware, it has got ARM9, it runs Linux. The application of this product is flow meter. Okay. Well, what we did was we designed this product for a company, and they installed this product on for measuring flow. But who's using it? The municipal corporations, Mumbai Municipal Corporation, PCMC, Bangalore, and they are going to go for all the municipal corporations of this country. And this is a device which is going to be fitted on each and every pipeline that goes out of the pumping house to the individual homes that the water is actually being supplied. Now, this is the one of the applications that I've just mentioned. Probably you all are here to design something like this. I want you to think of as if you are going to design this product. You have to be in the mode of application. So, electronics is a very fun game. I mean, if I were to say that, it's a fun part. But whole thing is you require to really learn a lot. You really require to develop a mindset to really come up with something like this. Okay. It's not a complex thing. Seemingly, if you look at this, so many things are there, so many PCBs, so many hardware. It's a very simple thing. It's the most simplest thing in the world. Provided you have the mindset, provided you have a zeal to learn new things. So that's what I want you to really make you understand. Probably you are here for designing something like this. Definitely career is one thing. You want to really work on with some company who will give you an opportunity to do something like this. But more than that, it's very small. Working for a company is a very small objective. Developing a career is a bigger objective. I want you to focus on that career point, path. And if you are thinking about a career, then you know what is to be done, what you need to learn. Because many people come over here just for the job's sake. I want to really get a job, and that's what they are all focused on. And then they really lose the entire career path. They get a job. At the end, the job is there for everyone. You just prove your point to someone who is interviewing you. You will get a job. And getting a job is not a big deal. Making a career is a real big deal. Now, I'll tell you in general. Since you all are here and attending an embedded system course, I would like to really give an overview to you about what is happening in the industry so that you can choose your career path accordingly. What has happened, initially if you really come and then see what was embedded all about, it was about small microcontrollers because the technology and the components available at that time and the applications that were there at that time was catering to very smaller segment of the application. So if I have got to do a monitoring of my home and then do some kind of smaller control system, I can really do it with an 8-bit controller, and I can just program it using the assembly language of that 8-bit controller and program. That was the objective, and that's what people were doing. Design, lot of design, lot of applications were designed exactly for that particular purpose. But as and when the technology moved on, the world started moving on, people realized that having a standalone application is not going to be of any use. You have to have an application that can connect. I need to really have an application which I can, from my cell phone, see what is happening in my home. So you may have a small control logic in your home which you monitor temperature, pressure, and the electricity and current and whatever things. But you want to get an access to that small application which is running on a small device. When I say application, I don't mean by application which is running on PC. Application running on a dedicated hardware. That's what we call it as embedded. So I can write a very small application to monitor my entire home security and everything. But what I require is I need to really find out what is happening over there. I don't need to really be at home to see what is happening. I can be anywhere out there. So connectivity becomes a very important aspect of modern world application, we talk about hardware, embedded or non-embedded, connectivity and networking is one of the important aspects. And that's what the entire aspect of embedded system development has moved on. People have come up with a lot of connectivity options like Ethernet. They're going to come up with wireless connectivity using GPS network nowadays. When the GPS was not there and the communication over the wireless network was a big headache. Now since we have GSM network everywhere, that becomes a very simplest and cheapest way of communicating over the wireless network. You don't have to worry about the wireless technology. You have a GSM network, just get a hardware GPS card, plug it into your application, ensure that your data is going from one end to another end. The another end could be an internet web application, or it could be a small device, that's my cell phone, where I have got another application to which I can really connect and see what is going to happen. That's where the development is starting moving. But along with the communication, there came a lot of challenges, because communication, if you see from the point of view of just passing the amount of data from one end to another end, it requires a whole lot of processing. A simple 8-bit controller would not be sufficient to really get the entire data out from one end to another end. Because if you just don't want the data from one end to another, you also want to do a control, you want to do more from that. Once you have a connection established, you want to get more. And that demand for getting more is something which is required to really come up with high-end processors. And that's where the things started migrating from small 8-bit controller to a high-end controller, like 32-bit, which can do more processing more efficiently. That's what once one requirement started giving birth to another set of products and another set of components available. And that's what people started utilizing those components and started making intelligent devices. We call it as so-called intelligent devices. What is intelligence in the devices is that it can communicate, it can talk. That's what. Now, also, what happened lately is that earlier embedded was only, people were thinking of embedded is a ball game of hardware engineers. I do my small PCBs, I get my 8-bit controller, I write an assembly language program, and I get my job done. That's my small application. It definitely was working fine. But the moment people started asking for more communication bandwidth, more communication network, more intelligence, things started moving from hardware game to software game. And then people started realizing, oh, assembly only, if I really do it in small program, it's not going to be helpful for me to add more features, add more intelligence. So people started adopting to high-level languages. Again, getting high-level languages as C was not sufficient. People started, okay, if I get a C program, what do I do about my TCP IP? Do I have to be entire TCP IP stack? What do I do about the storage? Because when I have a device which is intelligent, which can communicate, one of the intelligence that anyone would want to add is, what if there is no connectivity? What will happen to the device? Would it be a dumb device? People started, no, it should not be a dumb device. Rather, it should store the data somewhere locally. And whenever the connectivity is there, back again, just pass the data, whatever is stored, whatever is gathered, and then that's where people will come to know what has happened. And they will not miss any point, any data at any point of time. And then when you start about storage, people say, how do I store it? Okay, do I have a small EEPROM where I store the data, but the amount of data which was gathered was not sufficient for that EEPROM to really store that data. So you thought, no, I will not put a EEPROM over there, I need a bigger device. So what is the bigger device I have got available? Oh, I have got a SDMMC card, it's a 4 GB card. If I put a SDMMC card over there, it can do a lot of things. But writing data on the SDMMC card required the entire knowledge about file system. You thought, oh, do I have to write a file system then? Do you understand what I'm saying? So you had one problem and you started demanding more, problem became more complicated, and you said, okay, how do I solve this problem? You said, okay, this component can solve this problem. So what has happened is, when you talk about an application, it consists of a lot of components. Now, most of the components, if you see, are available in certain operating systems. Their operating systems are designed to be in such a manner that most of the components are part of the operating system. So the embedded software designers thought, why don't I put an operating system in my hardware? If I put an operating system, all those components are available to me. I have got a stack, TCP/IP stack, I have got a file system, I have got so many drivers, I have got so many other wireless connectivity protocols and all those stacks available to me. Why not I use it? And that's where people saying, okay, embedded software, let's have an operating system in it. And then they started debating, what kind of operating system should I really put into my embedded hardware? So people said, okay, you want to put a real-time operating system. Someone said, put Linux in it, put Windows on it. And that's the whole debate that we have to really be understanding. As an embedded software engineer, as a designer rather, there are a whole lot of options available to you. What suits best to your design is the criticality of modern world design. You have so many things available in open source, you have got so many things available from third parties and here and there. Now you look at it from the application point of view. What is your application going to require? And keeping those requirements in mind, you can choose those components from different available places. The requirement from the application can be cost, it could be size, it could be anything. It could be someone said that okay, my application requires that this device should be on forever. It should not really die unless you really lose the power. So as long as the power is there, my device is to be on. So that is a whole sort of requirement that you have to really start understanding from the design point of view. What we have done at this particular place is that we are giving you the fundamentals of everything. The bits and pieces are there for you to really understand. Now, if you are having a job mentality, you will look those individual things as individual components. So C is done, fine. What is the next one? Oh, 8005. Let me do it. That's done. What is the next? Done. And then you have done the entire course. And you say, what did you have done? You said, oh, I know these things, but I cannot connect them all together. I don't know how to apply them. I don't know how can I make something like this out of what has been told to me. If that's the mindset you are actually carrying over here from just the point of view of getting a job. Forget about job. Think about a career. I want to be a designer. If you give me a problem, I'm going to offer you a solution which is more optimal, which is going to be more cost effective, which is going to be more available. What I mean by available is that it will never fail. That is the mindset. What these individual models and bits and pieces that we have just are able to offer to you, you start connecting it from one another. So if we take care of C, you say, okay, C is something which, how to apply C? What can I do with this C, what has been taught to me? If you have an 8051 module cover, oh, previous module was C module, and then I have understood 8051 architecture. Can I write a simple application? If you start asking that question to yourself, can I write a simple application? Can I really go into the market and buy some cheap component and come and talk to the faculties over here? Oh, this is what I have a concept and I have an idea. I want to build this hardware over here. Can you really think in that manner? Because if you can do it, you have already connected these two models. And then comes, let's say, an ARM model. So he said, oh, now I have got more powerful processor available to me. What can I do with it? So whatever issues that you had with the other two modules, he said, I can overcome most of the things with this high-end processor that I have got now available to me. Think about another application. Can you really write another application using that ARM controller and do a more sophisticated thing for yourself? And then you talk about OS that we're going to cover, Linux we're going to cover, real-time operating system and stuff like that. Can you all put it all together? Can you think about an application something like this? Whatever I have just told you. Can you think about an application? Now this application requires you to have a high-end controller which runs Linux on it. It has got connectivity in terms of Ethernet, USB. From the sensor point of view, it has got analog input coming in which can sense level sensor. It can do from the communication point of view not only your Ethernet and USB, but it also has a 4 to 20 mA current loop. So 420 is something which is an industrial standard over here. Can you think about connecting these all bits and pieces and think about an application? You have to always be in that mindset about how to apply things. Science is something, if you have understood the difference between science and engineering. Science was all about discovering things. Engineering is not about discovery. Someone else has discovered. You think about how to apply those discoveries. Either for commercial purpose or for academic purpose or for learning purpose. Whatever is the purpose, ultimately you have to understand and you have to really create a mindset where you can apply things. So that's where if you start thinking, I'm not saying that you will be genius from day one. No one is genius over here. But the thought process itself is going to lead you to that position where you are really doing a design. Now, that's what I want. And I feel you all should be there at that position where you are actually contributing in designs. You understand the problems. When you understand the problem, you come up with a solution. The only way you can solve a problem is proper design. And that's what I think we can offer you, provided you take it in that manner. So you have to be now very much in the mode of getting things, extracting things. You are paid a lot of money, I don't know how much, but whatever money you are paid, you have to take return on that investment. Consider you have made an investment. Now you have to really get that investment back. Then only you will see paisa vasool factor. You will see my money is now being recovered. Now I am a better person, or whatever knowledge I had before this course, I am now a different person. I can apply things. I can now make a career. And I think it's a fun field. Embedded software, hardware, it's a fun field to really work on. And the entire world is now moving to devices. The era of PC is gone. You will not see any PCs anymore. I don't know how some years from now. There will be PCs definitely doing high-end job, but most of the day-to-day operations that you, me, our parents and our friends and our colleagues are going to use is small devices. PC is now going to be broken down into smaller pieces. I have an application on PC which is about, it's a picture. I'll break it down and I'll create a device of picture. You use PC for music, you break it down, music and videos, you break it down and create something like iPod or music player or video player. So you are actually going to break down entire applications of this PC and come up with individual devices. I'll give an example to you. We had one internal issue. When we had a project. The project was all about project management. So how do we really do project management? That's a different thing. So what we understood was, we use a lot of PC. On PC we have got a project management application from Microsoft and we use that a lot. We realized, oh, but that project management software on my PC is available only when I am in front of PC. But most of the people are not in front of the PC when they are moving around or they are doing their meetings. Still the project needs to be tracked. So what do we do? So remove that or leave that project management application on PC as it is. Let's create a project management software on an Android phone. So we have now at our disposal certain initiatives that people have taken like Android and a lot of other operating systems wherein we can build an application over there. And then what we realized, okay, let's get that project management from PC and put it on Android phone. So I don't need to be in front of PC. Wherever I am, I'm on field or I'm giving sessions or I'm doing my meetings, I can track my project, I can allocate new tasks and I can really get my things done from my people. And you know what that thing we did was, we actually broke one component from that PC and put it in one device. So a lot of things now PC, whatever is offering, that is going to be creating a new sort of devices for its own individual application. So earlier the thought process was get everything onto the PC. Now people are saying break the pieces, create individual application specific hardware. So if I'm doing just, you must have heard about routers and switches. Don't you think your PC is capable of doing routing? But do you think people use PC for routing purpose? No, Cisco has created a whole sort of devices just for routing purpose. Internally, what you will see there is an 8086 based processor, some ARM or Core PC or some kind of processor over there doing the same routing algorithm which the PC is going to do. Don't you think this projector over there, a PC can be put into this place of this projector? Yes, PC can also do it, but we don't want PC to really do those kind of things. So what we are talking about is applications. The applications can productivity applications, can entertainment applications can be about automation. So what we are trying to do over here is get the most out of whatever problem and then solve the problem in more efficient manner. This is going to reduce the cost. This is going to be more available for you to carry it around you, and that's what is the thought process I'm talking about when it comes to why so many people are talking about embedded. Why all of a sudden there are so many applications, so many processors, so many operating systems, so many people around there talking about embedded. So only reason is that now people want to really have devices which are intelligent, which can do more things. Most of the people are thinking about applications which can be derived from PC and put it in dedicated devices and then have it available. So all these are embedded applications. You have to just think about a problem, and the solution for it is something which you have to really start working on. What you require to do, they will definitely, when you come out of school, most of the things which are taught in school are more fundamental. Though definitely a lot of things are trying to are required or are conveyed over there. But most of the students that we found have lagging was they cannot connect the dots. They cannot connect the missing pieces in the puzzle. So here is a place where I feel we can help you in not only giving you those information about what is happening in the future and what is required to really build those things for the future, but also a thought process over here where you can connect the dots. Think about, as a designer, think about applications, think about solving the problem. That is what you can really get a mindset into. I think you have a career for yourself. Now, other thing that we have also observed is that when we actually get companies campus, companies into this campus, most of the people, though they are genius, they could be very good in terms of technology, in terms of their understanding knowledge, but they cannot present themselves to someone who is going to evaluate them. So if I am evaluating you, and you cannot tell what you are actually knowing or what you actually, if you're not able to present yourself, you have a lot of, very less chances to really get into any of these campus. So what we realize is that most of the people lag, I'm not saying all of them, all of you, but most of you lack something called as soft skills. You don't know how to present yourself. That's what our understanding is. You could be definitely very good in that. I'm not denying that fact. I'm not really challenging your personality and personal whatever personality you have. But if that is the assumption that we have, then it's our responsibility to provide you with certain soft skill modules so that you understand presentation skills, you understand interview skills, you understand group discussion, you can debate, you can do a lot of things. If that also can be built up into you, then definitely whatever companies which comes to this particular campus, you should be able to present it yourself in a better manner so that your probability of getting really a job and then you can build a career from that point onward can become a reality, and you can definitely realize most of the aspirations that you are having or you are carrying with you. Keeping that in mind, so we have certain modules also which is non-technological thing, but people take it very lightly. You know, in fact today I was checking up with the previous batch, how many people attended the soft skill module, and exactly the number was half. The other half of the people thought it is a useless module. What do I do? I'm anyway a smart person. The point is not whether you are smart or not. What harms you if you are present and you are just listening to someone who is trying to teach you? At the most, if you don't like it, you dump it and then you carry on with your thought process, whatever you have heard. But what if that person tells you a very, very different thing or a thing which is you are not aware of? What if you are being enlightened with some thought process which you never thought of before? That simple information is something which I feel you have to really look forward to and grab that thing. So that we can do some self-realization, you can build on your internal personality and you can develop yourself. That's what we think is more important than anything else. Whatever is being offered, don't treat it as a school. There is no, definitely we conduct tests for us to understand where you guys are leading or where you guys are moving. We conduct tests. Also to understand, are we really lagging somewhere? So the test is for both the purpose, not only to evaluate you, but also to evaluate our own methodologies that we are actually having. So, but we don't believe in this thing that if you score 90 out of 100, you are genius, and the one who's scoring 10 out of 100 is a dumb person. It's not the thought process. Believe me, scoring marks and scoring number is just a thing which is, I don't know, our education system is actually more towards scoring thing. Here there is nothing like score. You know, you have to understand the knowledge, you get the knowledge, you know how to apply things and you can solve the problem. That is more important to go. So think about that. So don't feel that you are here because you are here, your attendance is good so that you get more grades and good marks you can score so that you become an embedded engineer. That's not what is going to make you an embedded designer or embedded engineer. What really is going to make you is that you gain the knowledge. Whatever is being discussed over here, gather most of the things from there, and that is what is going to be more important for you in your career and in your personal life as well. If at all, that's important. So that's the thought process I want to really do. Okay. By the way, so the module we have definitely must be aware of it. So 4 months is something we are going to really have it on some training. 2 months is the project thing. Now we have an entire project lab. Now project lab doesn't mean a separate lab where you go and sit. It's the same place. But we have, as a part of project lab, what we have got is a lot of information which can be passed on to you. Not only the project itself, but also the individual components that are going to require. How do you do schematic? Because as an embedded engineer, though you could be really working on software, hardware is an integral part of the entire software, the embedded development. If you don't understand the hardware, you can really write an embedded software. Okay. So we are talking about an embedded lab wherein we will talk about schematic design, how to do schematic, and after understanding whatever project you have been allocated. Now, as per the schematic, what components you are going to require, you think about those components, we protect those components for you, build those components, come to connect and create a PCB for yourself, and then write an application so that you can prove that okay, you can apply things and you can really get it all right. That's what towards the end of this module, for 2 months you will be all involved in things. I want you to take most of it, whatever is being offered. One reason is definitely that if you are thinking about career, and I assume that if that is the reason you are here for, you will definitely take whatever is being offered to you. And then not only you just take whatever is offered, you also can counter and can gain more and ask for more. so that you can actually get most of it. That's what I want you to really think about. Being the first day today, it was my responsibility to convey that message to you. Because I don't come very often. My role over here is to see how people, my staff is working, if they are catering to your requirements, and if you have any issues, are they resolving your issues. So I look after those kind of activities over here at OSS. Okay. I'm accessible, but I'm accessible through a channel. You can just walk into my cabin and stuff. But yes, I'm definitely there to solve a problem. There is a front desk over there. You just put in your problem, and that problem immediately comes to me. I take personal interest in resolving those issues that you maybe really have. And if that can be resolved, then you can move on and you can start working on whatever is going on. Linux, one thing is the most important thing for today. You talk about, you cannot just think about Linux as some people doing something which I'm not related to. That's not the point. We have to really be working on Linux a lot. So from day one, we want to really ensure that you all are good in Linux. So you could be definitely good in Linux, but we will start with Linux as the OS, how to use commands, and how to compile the program. The entire C module works on Linux, and they have Linux. The reason is this is going to be an operating system that most of the embedded designs today are incorporating. Not that other operating systems are useless, but yes, people are using Linux a lot. The reason could be cost, reason could be recurring cost, because reason could be availability, reason could be anything, community and water companies. So it could be any different reason that people are using Linux for. But that's the most important aspect of modern world embedded development, be it software or hardware. So you have to also design at times the hardware which are very suited for Linux kind of operating system to run on. So there are a lot of things that you have to really understand. So Linux is going to be one important part of it. The other OS are also there. If we start covering each and everything, then even 2 years is not sufficient. So we thought maybe this is restricted to one OS. If you fundamentally understand it, you can apply the same knowledge to any other OS that you may really get access to when you start working in your career. Or when you are actually designing things, you say that, okay, here is an OS from Microsoft which is going to suit my requirements. So I would rather go with Microsoft OS. Fine. That's a perfect thought process. If your thought process is very clear, if you are thinking about design, optimization and all, go ahead and use Microsoft OS. There is no such thing as which is better and which is not so better. It's all about your problem. Whoever can solve your problem is the best thing available. Okay, that's the whole point. If I get a 4-bit microcontroller, that itself is going to be solving some of the other issues that I have. I don't need even an 8-bit controller. So there is going to be an optimal solution for each and every problem. As an engineer, you have to really think about optimization. How do I get more from less? How do I get more from less? I have got to do so many things. Because if you have a small problem, you can use an earlier analogy saying, use the entire PC, which has got so much of resources available to you. You can solve the problem on PC. But is it an optimal thing? No, it's not optimal. Can you get it to some small device? Then you can think about, oh, it's going to be cost more. How do I reduce the cost? So you start shrinking the cost, you start shrinking the area, the size and everything. So you compact everything. And you get more from that, whatever is less. So the cost less, it's more optimal. So the optimization becomes very important point of. You simply write a simple program and think about so many variables you have declared. You can do one more optimization. Can I get the same logic with less number of variables? Less number of variables, less memory consumed, less RAM, lesser RAM, so lesser cost, and the entire product cost goes down. So optimization has to be there with you. So you have to understand this part from day one. So optimization is something that you have to really put it in your mind and get everything optimally working. Performance, no compromise on performance, but at the same time, people want the same thing at lesser cost. So if you go to any shop over there and look at how your cousins and how your parents are shopping, they want everything in the world, but with a little cheaper and lesser cost. We all are aspiring to really get that. So how do you build such things which can be offered to consumers at a lesser cost? Cost is not the only factor though. There are many other factors which are also applicable at times. So think about all those things. I'm sure you definitely can have a really nice career. I want you to really be very good at what you do. no introduction. I thought introduction spoils a lot of time, so I'll skip that part. Anyway, I'll get to know you whenever I'll interact with you next time. My name is Rahul, and I sit just across the street on the other office, and you can get in touch with me through front desk. I thought maybe I should also start a support channel where you can directly write into the support, whatever issues you have. This is not working, that's not wrong, that's not right, you all are idiots, or whatever. You put it into there, I'll see how to resolve that thing. I'll see how you can really get much better. Okay. Any questions? Yeah. One question from my side. So you all are from what background? So you are electronics is the only background that you all are having?
I have an instrumentation and process.
Yeah, I'll come you very close to electronics.
Computer science.
Computer science. Not to worry, but just think about how do you really get it, because I'm not discouraging all those people who are not from electronics. I'm not scaring all those people who are not from electronics, but electronics is a very important aspect of embedded design. If you don't know it, this is time to learn it. Not knowing things is not a problem. It's always a good thing not to know things, because then you can learn it from scratch. And you definitely are not corrupted in your thought process. So that's very one aspect of that piece. But otherwise, it's a fun thing. What is required, a very important thing, a quality that you all need to possess is you need to have a lot of patience. A lot. Things are not going to work from the day you thought it should be working, or the day you think it should be working. The moment you touch upon it, you feel, oh God, it should work. And please, let it work, let it work, let it work. It is not going to be, you're not going to get results if you are just reading and not doing anything. Only thing which is going to help you is have a lot of patience. Keep your mind cool. Think about the problem. Think about why this thing is not. Instead of solving the problem for the mere sake of solving it, think about why is the problem over there. That's the question you should be asking. If I'm just thinking of an LED and that LED is not blinking, oh, I'm doing everything but this LED is not blinking. Think about why would it not work? What will make it not to work? Start thinking about it. Are the line connected properly? Are the driver in between working? Am I flipping the light? Am I flipping the correct IO line? Have I done the program right? So think about each and every aspect which can fail. Think about what can fail in between that solution and the problem. Okay? And in between, it's a whole big journey wherein you have to really keep it cool, you have to be patient, you have to really doing things, asking the same question again and again to yourself. Even though you say that this is right, but still ask yourself, is it really right? And then you can really solve the problem. So embedded, unlike other field, because it is very close to hardware, and the hardware is not proven. That's the real beauty about it. The hardware is not proven. Probably you are getting to touch the hardware for the first time ever. No one has actually touched that hardware. We talk about PCs, tested, fully tested and working condition comes to you. We talk about IO parts in the PC, fully tested comes to you. So you don't have to doubt the hardware even twice. But here things are built from scratch. It is tailor-made thing. Everything is tailor-made. Yeah, I have a small problem, I design my own hardware. That's what the entire things are very weird in embedded hardware and software especially, because the software is slightly close to the hardware. So you have to think about all those things which can break, and if you think about things which can break, it will really break. So the thing of patience is really required. You have to really be investigative, asking right questions to yourself, and then data sheet. At times you have issues with data sheet. The data sheet do not really convey the information in the proper manner. So you have to read the same data sheet 10 times to really understand what is actually being mentioned in that data sheet. And then maybe you get, oh, this is what is that they're trying to say, but I have understood it differently and I'm doing it differently. So let me correct it and see. That's what is the quality that you have to really start developing in yourself. And that's one thing I would like to say.